Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And welcome to my channel. In this video, we are going to learn about transformation of function. Moving the graph upwards, downwards, reflect the graph and so on and so forth. So we are going to learn how to transform. Transform here means, moving the graph around the coordinate system. So the first type of transformation that we are going to discuss is we call translation. And there are two types. Number one, moving the graph upwards, and the other one, moving the graph downwards. So now suppose that we have a number c that is a real number greater than 0, and our original function is called fx. Just name it fx. Now if we add a number c to that function, that is fx plus c, what will happen is that graph fx will be translated, will be moved c units upwards. That's if we add a number c, okay, to fx. But if we subtract a number c, okay, fx minus c, what I mean is fx minus c, then the graph is translated or move c units downward. So let's see an example first to understand this is what we call this transformation. Suppose that we have the original function fx is equal to x squared, that is a quadratic function. In this graph we have, using the color red in color, and we have another function gx, that is x squared plus 3. I hope you notice that gx is actually just fx, that is x squared, and then plus a number 3. So what happened if we add a number, as we discussed a few minutes ago, that when we add a number, then the graph is moved that number c upwards. Like in this case, c is equal to 3. Therefore, the graph is moved or translated 3 units upward. So instead of having graph red in color, now after we move 3 units upwards, now the graph will be in the position of green color graph. Okay, so every point on graph f equal to x squared will be moved upwards. Okay, 3 units. For example, point 0, 0 down here, we will move 3 points outward, or 3 steps down upwards. Okay, 1 step, 2 step, 3 step. So the new point is over there. Now the same thing goes to, for example, this point 1, 1. We have to move this point 1, 1, 3 units upwards. 1, 2, 3. So the new position is that one. Now, for example, point negative 1, 1, that point will have to be moved 3 units upwards. 1, 2, 3. Okay, that's the new position for that point, that is negative 1, 1. So you see, if we do for every point, we will see that the graph now, this graph, okay, after we join all the points, after we move 3 units upwards. Alright, another example, but this time when we translate the graph downwards, that is when we subtract 2.5 from f, that is f minus 2.5. Okay, we call the new function g. Alright, so as we mentioned a few minutes ago, that when we subtract, the graph will move downwards. How many unit? 2.5 unit downwards. Right. So if the point is point 0, 0, this point, we have to move it, okay, up to this point. That is, this point here is 0. Okay, this is 0, negative 2.5. That's the coordinate of the point. Starting from 0, 0. Have to move downwards 2.5 unit. Every other point also like that. So all point, after we do that, okay, after we move all the points on the red curve, okay, 2.5 unit downwards, we are going to have the blue color curve. Right, that is x squared minus 2.5. Okay, now another example, also downwards. If we have this graph that is y equal to or f equal to exponential x or exponent x. Now we are going to subtract 4 from exponent x. So the original graph is the red color graph. For example, if we take one point, in particular, this point here on the graph, that is point 0, 1. We have to move this point, that is 0, 1, downwards. Okay, 4 units. 1, 2, 3, 4. So that point will be moved to this point, that is now 0, negative, negative 3. Okay, that's the new point for 0, 1. Moving for 4 steps downwards. So if we do every point like that, then at the end we are going to have this curve, okay, blue in color. Alright, now how about this one? Okay, we are given this function f, and it is not given what is actually this function f. Okay, specifically, okay, we are just given this graph, okay, to represent the function f. Now we are asked to sketch the graph of fx plus 1. Okay, meaning to say we are going to move this graph 1 unit upwards. So let's do some points. For example, point 0, 0 here, we have point 0, 0. Okay, if we move it 1 point upwards, it will be over there. Now this point, that is pi over 2 and 2, if we move 1 unit upwards, it will be that point. Now let's see this point, negative pi over 2 and negative 2. If we move it 1 unit upwards, it will be somewhere here. Now how about this point? Okay, negative pi 0. If we move negative pi 0 1 unit upwards, it will be, okay, at this position. Okay, we have that. How about this one? Okay, pi 0, it will be at this point if we move 1 unit upwards. So I hope you see the graph will, okay, the new graph will be at this position, okay, roughly like this, roughly, okay, roughly like that. Join all this point like that, join all this point like that. So this is the graph of f of x plus 1, that is moving the graph f. Okay, this is the graph f, move the graph 1 unit upwards like that. Okay, let's see another example. That's all the example that we have for translating the graph upwards or downwards. All right, now let's move on into translation, still translation, but this time we are going to translate or move, okay, the graph to the right or to the left. Now suppose that c is greater than 0 and f again is still the same, that is our original function. Now if we subtract c in bracket like this, f of x minus c, in bracket we subtract c, what we'll do is it will translate or move the graph c units to the right. On the other hand, if we add c in bracket like this, f of x plus c, what will happen is that we'll have to move the graph c units to the left. Okay, I hope you take note of this. That is, if we subtract, the graph will move to the right. If we add c, okay, the graph will move to the left. How many units? Okay, c unit, depending on the value of c. Okay, maybe we can look at this example to understand better. The original graph is fx equal to x squared, the red one. Okay, and we are going to subtract 3 in bracket, x minus 3 square. Okay, and we call it a new function g. Okay, gx equal to x minus 3 square. So this function g is nothing but is originally a function f. Okay, f, but we subtract 3 inside the bracket. Okay, the origin of G is actually F. Alright. Instead of x square, we do x minus 3 square. So in this case, what we do is, okay, the graph is moving or translated, okay, 3 unit to the right. Okay, because we subtract negative 3, we subtract 3 in bracket. So for example, point 0, 0, that is this point, we have to move it 3 units to the right. 1, 2, 3. Okay, point 0, 0. Now move to point 3, 0. Right? Now, for example, point this point, that is point 1, 1, 1, 1. Okay, let's move it 3 points or 3 steps to the right. 1, 2, 3. Okay, that point. Okay, this point, that is negative 1, 1. If we move 3 steps to the right, it will be 1, 2, 3. That point. So if we do the same thing, we'll have that point. We'll have that point. If we do translate, okay, every point on red graph, 3 points to the right, we are going to have the points over here, so we can join, okay, this point, okay, and we are going to have the graph of x minus 3. Okay, so this graph is graph of x minus 3 square. The original graph is x square. Okay, what will happen is x minus 3, the graph move to the right 3 units. What we call the shape of the graph is still the same. The orientation is still the same. That is, orientation means it's opening upwards, and the shape is still the same. The size is still the same, just that the graph is moved. Instead of having minimum at 0, 0, right, over here, now the graph having minimum at 3, 0. Okay, everything is the same except the position, okay, already changed. All right, so that's what if we subtract in bracket 3 happens. Okay, the graph will move to the right 3 units. Maybe we have some more example here, moving to the left instead to the right. Okay, this time we move it to the left. So to the left, what we'll do, we have to add, for example, in this case, x plus 2 square. So if we have like this, means that we have to move the graph 2 units to the left. When we add, we have to move to the left. How many unit? Okay, 2 unit in this case. Okay, for example, point 0, 0. This is point 0, 0 here. Point 0, 0. Okay, if we move it 2 unit to the left, it will be, okay, 1 unit there and another unit. Okay, so it's become point negative 2, 0 like this. So point 0, 0, okay, translated to point negative 2, 0. Okay, the same thing, other points also. For example, point 1, 1, that is this point. Okay, if we move it 2 units to the left, we'll have 1 point. Okay, it will be over there. And that point will be over here. So we'll see the same thing happen. That is, okay, we are going to move the whole graph, okay, to a new position. That is the blue graph. Okay, that is after we move the red graph 2 steps to the left. All right. Now let's see different type of function. This time we have a log function. The red curve here. This is a graph of 5 log x. All right. Now if we add 2 in bracket, okay, still we have 5 outside, 5 here, and we have still 5 there. The only difference is for f we already add 2 and we call it a new function g. So now g is equal to 5 log x plus 2. See, in bracket we add 2, right? So what will happen to the graph is we have to move it 2 unit or 2 step to the left. Okay, so let's choose 1 or 2 points to show that we really move, okay, points on the red graph to the left 2 steps. For example, point here. This point is point 10, right? Now let's move this point that is 10 to the left 2 steps. Okay, 1 unit and 2 unit. Okay, so point 10 now becomes point -1, -10 after we move to the left 2 steps. All right, and the same thing goes for other point also. That is, for example, this point here. Okay, this point is 2, and the value of y is 1.5. If we move this point 2 units to the left, okay, this is 1 unit here. We have to watch the scale. This is 1 unit, and this is 2 units. It's become that point. It's become now 0.0, 1.5. Okay, that's the new position of this point after we move to 2 step, okay, to the left. All right, so if we do for every point, we can join all the points together, and we are going to have the blue curve, the blue graph here. Okay, after we move all the points on the red curve 2 points to the left. Okay, why we move to the left? Because in bracket we have here x. Okay, x plus 2. All right. Now we have okay, an exercise here, and see whether we can do this. Given the graph of fx, okay, the red one, okay, this part and also this whole part, the red graph all together is graph of fx. Now we are asked to sketch the graph of f of x minus 3. You see here in bracket we subtract 3, right? So what will happen to the graph? Okay, that's the question. So we know that we have, okay, the graph. If we look at the example previously, like this one, see, when we add 2 inside the bracket, we move to the left. Now here in this case, we are going to subtract 3 in bracket also. So what will happen to the graph is, okay, we have to move every point on this graph 3 points or 3 steps to the right. Okay, now for example, this point 0.00, okay, if we move this point 3 steps, okay, to the right, now that point, that origin now is become 0.30. That is this point 30 after we move 3 points to the right, because we are going to move everything 3 steps to the right. Okay, so that is, okay, the new position for 0.00. Now let's see another point. For example, this point here, this coordinate is -5 and 5. All right, now we want to see what happened to this point. Okay, if we move that point 3 steps to the right, 1 step, 2 step, 3 step, okay, that point will move to this new position, that is point what, -2, and the value of y is still the same, 5. Okay, now let's see this point, that is 0.55, 5, 5. What happened to this point if we move it 3 steps to the right? Okay, 1, 2, 3. Okay, it will be at that point, at this point here. So okay, since this is a straight line, over here on quadrant number 1 also a straight line, we better use ruler to sketch the graph, you see. But here, okay, in this demonstration, I'm going to just use freehand to sketch the graph. Alright, so this part, this component, just like this, and over here we have another one like that. Here, so that will be our new graph. So if we want to label it, yes, this is fx, the red one, and the black one, this is f of x minus 3. Okay, after we move the red graph 3 steps, okay, to the right. Okay, that's about translation. Okay, translation 4 type. Number 1, upwards, downwards, to the right, to the left. Okay, 4 types of translation. All right. So now, okay, we can live with translation, and we are going to discuss about the new type of transformation. We call it reflection. And reflection only two types. That is, okay, reflect about x-axis and also reflect about y-axis. Now, the first one is to reflect about x-axis. If we see that f is now multiplied by -1 like this, when we have negative of fx, that means that the graph of f is reflected about x-axis. All right. Now, to reflect about y-axis, what we have to do is we have to multiply -1 inside the bracket like this, f of negative x. What that will do is, okay, the graph will be reflected about y-axis. Remember, if we multiply -1 outside, the graph is reflected about x-axis. If we multiply -1 inside the bracket, the graph will be reflected about y-axis. Okay, let's see some example to help us to understand what we mean by reflection about x-axis and y-axis. For example, in this case, we are given fx equal to x squared. Okay, the red graph, that is this one, facing upwards, right? Facing up. Now, we are given gx equal to negative x squared. Okay, please take note that we are multiplying -1 by x squared, meaning to say, okay, this graph of f is reflected about x-axis. Okay, now what we mean reflection is that as if that we have a mirror at x-axis, and x-axis is called now axis of reflection. Here it is, axis of reflection. All right, axis of reflection. Okay, so if we reflect, for example, let's choose one point on the red graph. For example, over here, this point is what? -1 and 1, right? Okay, we are going to reflect about x-axis. So this distance and the distance between the axis and that new position must be the same. So this is 1 unit, this also must be 1 unit. Therefore, this point is reflected to this point. All right. Now the same thing goes here, that is at point 1, 1. Okay, this is 1 unit. Okay, from the axis of reflection to this new position also must be in 1 unit. So point 1, 1 is now reflected to point 1, -1. Over here, from -1, 1 is reflected to -1, -1. That's the new position. Now point 0, 0, that is the origin, since it is exactly located on the axis of reflection, therefore it won't move. Okay, it will maintain the position still at the position of 0, 0. So we can check out some more points. For example, point 24, for example, this point here, point 24, this is 24. Now the distance between point 24 and the axis of reflection, this one is 4 point or 4 step. Therefore, the distance between the axis of reflection to the new position also must be 4. Therefore, the new point for 2, 4 must be this one. That is 2, -4, like that. Now, if we do the same procedure, point -2, 4, okay, will be reflected at this point, -2, -4. Okay, we can join these points together. All right, we have 1, okay, 1, 2, 3, 4, 5 point. If we join them together, we are going to have the blue color graph. Okay, that is the reflection of the function x square. All right, so that is the answer for this one. That is, after we reflect x square, uh, about x-axis, the answer will be the blue color. So we can say this one is fx. So this is fx. This is graph of fx, and this will be the graph of negative of fx. Okay, negative 1 multiply outside the graph, outside the function, I mean. Okay, another example of reflection about x-axis is this one. That is, this time we have an exponential function, the red color graph, you see. And still we are going to multiply negative 1 outside, meaning to say, okay, the graph will be reflected about x-axis. All right, so this is our axis of reflection. Okay, let's take some point here. For example, we have this point. This is 0, 1. And the distance between 0, 1 to this point is 1. Okay, therefore, the new position of that point after reflection about x-axis must be the same between the point, the axis of reflection to this new position. Okay, so point 0, 1 now is reflected to point 0, negative 1, like this. Okay, and so on and so forth. We take, okay, many more points. We'll see that, okay, we'll have the points, okay, below x-axis, and if we join all these together, we are going to have the what called the blue curve, like this. All right, so if we are going to label this, this is the graph of fx, and this is the graph of negative of fx. Okay, in particular, this is the graph of exponential x, exponent x, and this is the graph of negative exponent x, like that. All right, let's see if we have more example on that. Yeah, this time we are going to see an example of reflection about y-axis. Right, for example, we have log function, log x, that is red color graph, this one. Okay, and this time we are going to multiply negative 1 inside the bracket. That is log of negative x. Okay, negative 1 is multiplied inside the bracket. Okay, therefore we know that this graph will be reflected about the y-axis. Therefore we call y-axis as our axis of reflection. Okay, so where will be the position of the new graph, okay, after we reflect about y-axis? So what we can do is, okay, for example, we take one particular point, this point, that is point 1, 0 there. Okay, the distance between point 1, 0, okay, to this point, that is isometry, is 1, right? Therefore, the new point after we reflect, okay, about the y-axis, point 1, 0, okay, the distance must be 1 also. So the point will be over there. Okay, and we can continue doing this. For example, this point here, okay, the distance between here is, okay, 0.4, something like that. Okay, and the distance from that point to this point also must be the same, that is 0.4. So the new position for this point is this point, so we can join them together and we can have the blue color function as the graph for log of negative x. So if we label this graph as f of x, now the blue one will be f of negative x. Okay, reflection about the y-axis. So the y-axis is called axis of reflection. Okay, now let's try, okay, to do this exercise. Given the graph of fx, that is the red graph here, we are asked to sketch the graph of f negative x. Okay, inside the bracket we have negative x, and we know from our discussion just now that if we have in bracket negative x like that, what that means is the graph, okay, of fx is reflected about about y-axis. So let's um, refer to some points, okay, on the graph of fx. For example, let's take this point. This point is -2, -2 and 2, okay, and we know that this is our axis of reflection. All right, so the distance between this point to the axis of reflection is how many unit? We have 2 unit there. Okay, therefore the new position after reflecting about y-axis for this point must be 2 unit also from the axis of reflection. 2 unit, okay, must be up to here, and this will be the new position. The new position is what? 2 and 2. Okay, that's the new position of -2, 2. All right. Now, how about point 0, 0 here? Okay, since it is located exactly, okay, on the axis of reflection, therefore that point won't move. Okay, that point maintained. Okay, still there. It's not moving anywhere. All right. So we have 1 point here and 1 point there is enough for us to sketch this straight line, because this is just a straight line, enough for us to have 2 points to join them together. Okay, I hope you can do that by using ruler and maybe pencil, okay, and join this point together. I'm going just to use free hand to, to join these 2 points, and of course it will not be perfect like this. So if this is fx, so this is fx, okay, this graph will be f of -x, reflection about y-axis. Okay, now let's do this question here. Very interesting question. Given that this graph is the graph of fx, now we are asked to sketch the graph of negative of fx. Okay, now I hope you still remember what happened if we multiply -1 outside, like this, negative of fx. What happened to the graph? Yes, it will be reflected about x-axis. All right, reflect. Let me write it down. Reflect about x-axis. X-axis. Okay, so this is x-axis here. This will be our axis of reflection, like that. Okay, so this graph, take this point now. That is point 4. I mean 0, 4 there. Now, the distance between this point to the axis of reflection, 4, right? 4 units. Therefore, the new position of that point, that is point 0, 4, will be 4 units also from the axis of reflection. Therefore, the new point will be here, that is at 0, -4. Okay, please take note that point 20 and point -20 is on the axis of reflection. Therefore, that 2 points will not move, it will stay, okay, at the same position. All right, now let's see, maybe we can use some other point. For example, let's see, okay, I think that will be enough for us to reflect this graph, okay, downwards, okay, about y-axis, I mean x-axis. So we can sketch this part first. So we can have the graph like this. All right, that's for this component, this part. Now for this part, okay, if we reflect this part of the graph about x-axis, the graph will be, okay, reflected, okay, above y-axis. Okay, the graph will be look like this. Okay, now on this side also, for this part, the graph will be, okay, on this side, on quadrant number 1. Okay, so if this is the graph of fx, this graph will be the graph of negative of fx. That is a reflection about x-axis. Okay. Okay, that's examples relating to reflection about x-axis and also y-axis. Now the next type of transformation of function is what we call compress and stretch. Compressing and stretching. The graph can also be compressed. The graph also can be stretched. Right. Now suppose that c is greater than 1. I hope you notice that previously for other transformation we have to consider c greater than 0. But for compressing and stretching, then the value for c must be greater than 1. Alright. Now we are going to take the same function f as our original function. Now to compress a function vertically by a factor of c, what we have to do is we have to multiply f, the function f, by c. Okay, where c must be greater than 1. If we multiply, okay, a number greater than 1, we multiply by f, we are going to compress the function vertically, okay, by a factor of c. Now that's compressing. Now for stretching, what we can do is we can multiply the function f by 1 over c. Now since c is greater than 1, therefore 1 over c will be less than 1, meaning this will be a small number less than 1. Okay, if we multiply a number that is less than 1, multiply it by a function, what will happen to the graph is the graph will stretch, meaning the graph getting bigger. Compress mean the graph getting smaller. Okay, we will see some examples related to compressing and stretching. For example, this graph here, very familiar example, graph of x square, the red one. And we are going to multiply the graph by 4. Therefore, we get our new function gx is equal to 4x squared. So if we multiply 4, okay, multiply by x squared, what happened to the graph? You see now the graph getting smaller, or what we call, okay, so-called compressed. The graph is compressed, getting smaller. Yeah, that's because we multiply x squared by a number greater than 1. Okay, 4 is greater than 1. If we multiply a number greater than 1 to a function, the graph will compress, will getting smaller. Now it's compressed vertically by a factor of 4. What that means is, okay, let's see. Originally, for example, we take one point. This point, for example, that is point 1, 1. Okay, point 1, 1 is on our original graph. That is, this is fx. This is fx. All right, the original graph. 1, 1 is on that graph. Now, when we multiply the function by 4, what happened is that 0.11, now the value of x is still the same. Okay, the y component, that is 1, we have to multiply by 4. So 1 multiplied by 4 will be equal to 4. Therefore, 0.11, this over here, now becomes 0.14. You see, the y component have to multiply by 4. Now, the y component mean it is vertical component of the graph. Okay, this is what we mean by compressed vertically by a factor of 4. Okay, the y part we have to multiply by 4 depending on the value of c that we have. In this case, we have 4, right? So we have to multiply the y component by 4. Now, the same thing, for example, if we take on our original function fx, take another point. For example, we take this point here. This point is 2, 4. All right, 2, 4. Okay. Now, that is on fx. Now, if we multiply f by 4, okay, what happened is this point now, okay, will be transformed into a new location, new position, that is 2. Okay, what's the y component now? Yeah, 4 we have to multiply by 4 also. 4 times 4 is 16. So where is point 2, 16? Yeah, it's over here somewhere. This is 0.216. Okay, what happened is that 0.24 now, okay, has been moved to 0.216. Alright, that's what we mean by compress vertically by a factor of 4. Now, the same thing goes to every other points on the red graph. Okay, will be the same effect because we multiply by 4. So we are going to have the graph blue in color. Okay, this graph is already in the form of compressed. See, the graph is smaller if we compare to the original one. All right. Now, in this example, we have fx equal to x cubed. Okay, we are going to multiply by 3 this time, and also the graph will compress because we are multiplying the function by a number, okay, that is greater than 1. So, for example, if we take point 1, 1 here, 1, 1, since we multiply by 3 here, so the y component will have to multiply by 3. So the point that will be 0.1 times 3 is 3. So 0.11 becomes 0.13. Okay, that point, and so on. So if we do every point on this graph, on the graph of x cubed, we are going to have the graph of 3x cubed. That is the blue one. See, the graph becomes smaller. Now, let's see. Yeah, this is an example for stretching. For the previous one, that's example of compressing. Now this is for stretch. Now we multiply, for example, fx equal to x squared, we multiply by 104. See here, 104 is less than 1, right? So what happens is that the graph will stretch. The graph will become bigger. Say the original graph is the red one. After we multiply 0.25 or 104, the graph will become the blue one. The graph becomes bigger. So what happened is that suppose that we choose one particular point here, like this one. This is point 24, right? So where will be this point, that is 0.24, after we multiply 1 over 4 times x squared? Now this point will change to the x component is still the same. Now the y component 4, we have to divide by 4. So 4 divided by 4 is equal to 1. So this point, okay, will move to 0.21. That is this point. All right. So every y component of the points on this graph of fx, we have to divide by 4 or multiply by 1 over 4. So at the end, we are going to have this graph that is blue in color. All right. So now the same thing, if we compress the graph by a factor of 2, because here we are multiplying fx by 2. If we look at one or 2 points here, for example, we have a point. For example, we look at 2, 2, 2. Okay, let's see this one, 0.22. All right, 2, 2. That is on the original function. Now, since we are multiplying by 2, see here, we multiply this function f by 2, so we have to multiply the y component. The x component is still the same. 2 times 2 is equal to 4. So the new position will be 2, 4. That is this point. So if we do every point like that, or maybe a few points like that, so we can have the graph that is blue in color, right? So that is after we compress by a factor of 2, because we multiply f multiply f by 2. All right, now in this example, okay, we have 0.5 multiplied by fx. Okay, 0.5 is less than 1. So this is 1 over 2. Therefore, we are going to have stretch. This graph will stretch. Okay, now for example, let's say point here 0.44. All right, 0.44. Okay, this one 0.5 is equal to 1 over 2, right? So the y component, okay, we'll have to divide by 2. So 4 divided by 2 is equal to 2. All right, so 4.44 now becomes 0.22. 4.42, sorry, 0.42, this point. Okay, so how about the other point? This is still the same. Okay, how about on this side? So let's take this point. All right, so we have negative 4, 4. Okay, this 4 also we have to divide by 2. We are going to have, okay, this point will be moved to point negative 4, 2. Negative 4, 2 is somewhere here. So if we take a ruler and pencil, we can join this point together. They have the same shape, but it's already compressed. I mean, in this case, stretch. Okay, getting bigger. So if we sketch the graph like this will be the that on the right hand side, and also this one will be on the left hand side, the graph like this. Okay, this is the graph of fx. Now the black one here, okay, use ruler and pencil. See here, because I have this type of graph because I'm using freehand to draw it. So this is 0.5, okay, f of x. Okay, the graph already stretched. All right, let's see this example here. Okay, we have, and we are given the graph of fx like this, the blue graph, and we are given negative of f of x minus 2 and then minus 1. There are a combination of operation here, okay, transformation, combination of transformation. We have first negative. Okay, let's do it one by one. Number one, okay, let's do this one first, negative fx. Now this is fx, right? So if it is negative fx, okay, we are going to reflect this function about x-axis. So this will be the same position, Now this point will move to, okay, instead of 0, 2, now become 0, negative 2 down here. So the graph will be this one. This will be the graph. Okay, this is number one. Okay, now for number 2, what we have to do is negative of f x minus 2. See here in this bracket x minus 2, meaning we have to translate the graph 2 step or 2 unit, okay, to the right. So let's move this one to the right 2 unit, 1, 2, that point, okay, is moved there. Now this point 2 unit become 1, 2 over here. Okay, this point, if we move 2 unit to the right, 1, 2 is over here. So the graph will be, let me use this color. Okay, it will be this graph. This is number 2. After we move the graph 2 unit to the right. Now, for number 3, we have negative of x minus 2. We have to subtract 1. Now, subtract 1 here means we have to move the graph 1 unit downwards. So, the same position, but move the graph 1 unit downwards. So, let's use this color. 1 unit over there, downwards. 1 unit downwards will be, that point will be moved over here. Okay, this point will move to this point. So the graph will be this one. Okay, this is number 3, and that will be the graph of this whole thing. All right. So if this is f, okay, this is f, this will be the graph of negative f of x minus 2 minus 1. Okay. All right. That is a good exercise, I think. Now, this is also a good exercise for us to do, to sketch the graph of this function, So, for this particular uh, question, what we have to do is we have to do what we call completing the square, because we want to make a relationship okay, between this graph and the graph of x square. So, well, let's write it down. That is, we have fx equal to x square minus 4x plus 3, right? So, okay, let's do this first. So this is equal to x square minus 4x. So what I'm doing now is completing the square. Very important concept in mathematics. Okay, completing the square, and we have a lot of application of it. One of it is over here. X square minus 4x, okay, plus 4, okay, plus 3. You see here, I just add this 4. I have to subtract 4 to cancel it again. So what I have is x minus 2 square, and 3 minus 4 is equal to negative 1. Okay, so this thing is equal to this thing. Alright, after we do completing the square. You see now, this graph is actually, okay, has a relationship to this graph, that is fx equal to x square. So actually this graph is what is, okay, originally this graph x square, okay, we minus 2 inside the bracket, meaning we move the graph of x square 2 step or 2 unit to the right, and then we move 1 unit downwards like this. All right. So number one, what we have to do is, okay, we are going to look at the graph of x square. Number one, what we have to do, we move, okay, 2 unit to the right. Okay. Number two, move 1 unit downwards. Okay, that's what we have to do. So first of all, what we have to do is we have to sketch the graph of y fx equal to x square first. So we have to sketch the graph of fx equal to x square. This is the original graph. All right, x square passing through 0 0, 1 1. All right, when x equal to 2, y equal to 4. Okay, this way. 3, when x equal to 3, y equal to 9. Where's 9? Over there. The same thing when the value of x is negative. When x is negative 1, the value of y is 1. X negative 2, the value of y is 4 over here. We have when x equal to negative 4, the value of y is equal to, 3, 9. 3, 9. Okay, I think that's enough to sketch the graph of fx equal to x square. So we join this point like this roughly. Okay, I have to pass through every point. Sorry about that. There are some points that I haven't passed through. Okay, supposed to go through every point. Now that's the graph of fx equal to x squared. So the first step, what we have to do is, okay, we have to move this graph of x squared 2 unit to the right. Okay, 2 unit to the right. Okay, now let's move 2 unit to the right. Now 1 unit over there, 2 unit. Okay, so we have 1 1, okay, 2 unit. All right, so that's this point, 1 unit, 2 unit. All right, so this point, 1 unit, 2 unit is become over there. Okay, now this point, 1 unit, 2 unit is become over here. Now this point, 2 unit to the right, 1 unit, 2 unit, like this. 1 unit, 2 unit over there. Now this point, 1 unit, 2 unit over here, and this one, 1 unit, 2 unit over here. So if we join this point, okay, pass through all this point, we have the graph of, okay, this is after, okay, if this red one is f equal to x square, that black one is actually equal to x minus 2 square. Okay, we have one more step here. We have to move that black graph, okay, 1 unit downwards. Yeah, so we have to move it 1 unit downwards. Okay, so let's use this color. So 1 unit down is this point become that point, this one that point, this one become that point. Now this point become supposed to be that point. Okay, this one become this point. Move 1 unit down like that. So if we do that, we can join all these points together. Like this. So this will be the answer that we are looking for. That is x minus 2 square minus 1. Okay, roughly. Okay, the graph will look like that. So the answer is this one, the blue color graph. Okay, let's see. This example here, we have okay many graph is located here. We have f1 up to f5. Okay, the graph f1 is the graph of modulus or absolute value function. That is the red color graph. Okay, this one. This is number 1. Okay, and then we multiply by 2. Now what happened if we multiply a graph by a number 2 like that? It will compress, right? So compress. Now this has become number 2. Okay, and then we subtract 2 in bracket minus 2. So we move to the right 2 step. Okay, from blue now it's become green. This is number 3. Okay, number 3. Okay, we done up to there. And then we minus 1. Minus 1 means we go down 1 step. This is number 4. The purple one, this is number 4. Okay, and then for number 5, we multiply by negative 1, meaning reflect about x-axis, and then we plus 4, meaning move 4 step to the left. So this one number 5, that is reflect about x-axis and then move 4 units to the left. Okay, now the last part of today discussion is this graph. Okay, maybe you can try this. Okay, sketch the graph of fx equal to x squared plus 6 plus 11. It's almost the same as this this question, that is the sketch the graph of x squared minus 4x plus 3. So what we have to do is we have to use completing the square, and then by referring to the graph of fx equal to x squared, then we can modify, okay, and move around the graph and see where will be the answer to the graph for this function x squared plus 6x plus 11. Okay, look at this example. Okay, it's almost the same problem with only different numbers. Okay, that's all for now. We'll see you next time. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.